Hi, welcome to the lesson for volume of a cylinder. Today we're going to be talking about how to figure out how much would go inside of a cylinder, if you will. So we have to go back a little bit, talk about some vocabulary. Eventually we're going to be able to solve these two types of problems. Is the big deal today. That's the essential question. Can you solve volume of a cylinder for either the volume or the height, depending on what they give you, using the formula right here. So let's talk a little bit about review. First of all, back when you were in seventh grade or sixth grade, you talked about these types of things. Now, forget the Kleenex is on top. If I push that back down in there, this should be considered a rectangular prism. Rectangular prisms have some features that make them special. First of all, they have flat sides, surfaces, if you will. Some of them are equal to each other depending on the prism. In this particular case, we would find out we could do surface area or we could do volume. Volume would mean how much fits inside. If you were to take little cubes, how many little cubes would actually fit inside of there? That's why when we do volume, we have the label cubed instead of squared. Squared would be flat surfaces. If we broke it down to a net or some other type of structure, we would have a net and we'd have a flat surface, which would be squared. So that's the difference. So this would be a rectangular prism, and this right here would be a cylinder. Notice, circles is the big difference here. They look like they're pretty similar. This one's a little smaller than the prism, but they're a little bit different with how you figure them out. Now, if we were to try to figure out the volume of this, we would go base times height. And of course, the base would be the two sides multiplied together times the height. So this is like 5, and that'd be 5, and 25. Let's say that's 6, that'd be 25 times 6. You would have the volume, base times width times height. Now, or not base, it would be base times height. We figure out the base first and then multiply the height. Now, if we start talking about a circle, or a cylinder like this, we're talking about the base having a circle involved. So with that, we have to use some different vocabulary. We've been working on with pi and radius and diameter, things like that. And then we could also figure out the height. So if we look at the vocabulary we have to review, we have area. Area would indicate how much space it would take up, how much of the surface area it would be. Composite would mean if we put more than one figure together. For example, maybe we have a rectangle and a triangle put together. We would be composing them, putting them together, composite figures. Radius, remember, would be half a circle. If you see this little dot in the middle right here on the lid, you can see that that would be half of the way across. And then diameter would go all the way across. So those would be the two big terms you would see. We'd indicate those by a D or an R, depending on how you want to label them. And the most important thing we need to know today is pi. We talked about this a little bit before in class. Pi we can indicate with a fraction as 22 sevenths or 3.14 as a decimal. We typically use the decimal on a calculator. Calculator would be acceptable for this. It's an appropriate tool that you could use strategically, so it would have no problem with that if you want to put that in as you solve them. And the symbol for pi, mine isn't perfect, but it's okay. It's got two little lines and then the little thing on top there. So this would be pi. We're going to be using that today as we go through. Let's start with the board here. As we start out, first of all, what do you need today? You're going to need a pencil or something to write with and a piece of paper. The expectation is that you participate and not just watch. So when we get to these two problems, I actually want you to draw them and try to figure out the answer as you go, so that way you can check and see how you're doing as we go through, if you're getting them correct or incorrect, and we'll have a couple practice problems at the end for the class that you're in. So I'll lead you to those through the Google link that we have as well. So the volume of a cylinder, right here, we have the area of the base. Now the base could be either on top or bottom. It doesn't matter which one you indicate as the base because they should be the same. Like on the can that I had, we have the top and the bottom. They should be the same unless you have some kind of a cone situation, which we'll talk about later. And the height would go like that. Base, we have a big B to indicate base. We have an H for height to indicate the height, which leads us to our formula. Volume equals base times height. So in this particular one right here, they don't give us any measurements, so we can't solve it. It's just giving us a layout of how they were going to look. The big key here you have to remember for the base is in seventh grade, you learned that the base for a circle like this would be pi times radius squared. So if you had a calculator, you would put in either the pi button or 3.14 is accepted. So 3.14 times whatever the radius is, and that would be squared. So you'd actually do the squared part first. So you'd go 5 times 5 or 6 times 6, whatever it would be, and then multiply it by pi. So let's start off with our first example. All right. So I'm going to put down some numbers on this. I'm going to make it a little more real. So instead of just saying that this top has nothing to it, we're going to say that the radius, halfway across right here, boom, is going to be 3. And just for fun, let's call it 3 meters. We'll give it a label. And the height of this particular cylinder, let's make it be 6 meters. So you're thinking, okay, what can I do with that? Always recommend starting out with the formula. So volume equals base times height. I'm going to move this over and up a little bit so you can use it. Let's just slide it right up here for now. So we have volume equals base times height. The volume we don't know. That's what we're trying to figure out. That's the missing part. But the base would be 3 for the radius. So we don't have it yet. We have to use this to figure it out. So we have to go radius squared times pi. 3 times 3, anybody know? Probably 9, right? So we got 9, and we're going to multiply it by 3.14, and we're going to end up with our deal. So here, let's set it up now. So I'm going to go pi equals 3 squared. Remember, that's our radius there, and we're going to square it. So we have 3 squared, and we're going to multiply all that by 6. So if we solve that, we're going to end up going 3 times 3 times 6. If you use your calculator, that should give us 54 pi. So I'm going to rewrite it like this, 54 pi. And we're going to have, actually this would be, sorry, pi times that. Volume would equal pi times that times that. So looks like that. There we go. So if I'm going to take all these numbers and I'm going to consolidate them into 54. I'm going to leave pi as just pi because we know that we can go 3.14 times 54 will give us our approximate answer. So we're going to have 54 pi is going to be about, so I'm going to make a squiggly equal sign like this, about 169.6. We usually round it to the tenth so we don't have a giant long number there. So the volume of this particular figure would be about 169.6. Of course, we have a label, so we should keep our label. So we got meters cubed, like we said. So we have meters cubed. So this would be the first type of problem that we have, would be the first one that's up there. Now, what, though, would we do if we had to find the height instead, or one of the other missing ones? All we're going to do to find the missing stuff is we're going to use the formula, but use it in a little bit different way. So let's rewrite a new type of problem here. I hope I don't drop my board. We'll see how it goes here. So I'm going to erase this quick. And if I erase this, I should have enough space to set up my next problem. That looks wonderful. I gotta get some cleaner for this thing. Okay, so here's my second example. I'm gonna make kind of a vertical one instead of a, well, horizontal. I guess vertical, it's a cylinder, it doesn't really matter. So I'm gonna set it up this way though, almost like a hamster wheel. I'm gonna go like this, and then I'm going to make that there, like that. These little dots mean that you can't really see it. It's like hidden behind there. And I'm gonna make this be my diameter all the way across, and I'm gonna indicate that it's 10 inches. For the entire diameter, all the way across that thing is 10 inches. But we're going to take a height as our missing number. We don't know the height here, so we're going to leave it as height. What we're going to do is tell you the volume. So the volume for this entire thing is going to be about, remember, because we got pi, we're not going to go exactly to pi, it's going to be about 314 inches cubed. So you're thinking, okay, well, I'm missing the height, but I have everything else. What should I do? The formula is key. So grab that formula. Volume equals base times height. So volume equals base times height. Do we know the volume? Yes, we do. 314. So I'm going to plug it in. 314. Oh, it probably should be an equal sign, should it? It should probably be more like that. So volume equals that. Do I know the base? I do. 10. Well, is it 10? It would actually be, remember this, it would actually have radius squared, but we don't have the radius, we have that. So 5 times 5 would be 25, and then we'd have 25 times pi there, I guess. We have 25 pi. We're going to say the base is 25 pi times the height. We don't know the height. That's the missing part here. Well, we learned before that if we have something missing, we have a variable, we want to get it all by itself. So the way that we're going to do it here is we are going to take and divide to simplify that back out. So we are going to take this and we are going to solve. So 25 times pi. Now this is the place where if you have a calculator, you're good to go. Let's see what happens. I'm going to plug it in. So I'm going to go 25 times 3.14. I got 78.5. That's interesting. So let's check it out. So I have 78.5 like this. And we still have height that's missing there. And it's approximately 314. Okay. So what would happen if I were to divide that? So 314 divided by 78.5 gives me 4. Worked out exactly, which is awesome. Thanks a lot, math book, right? So I'm going to have 4 is approximately H. Now we could also talk about the label here, but in this case, we could say 4 inches. We could leave it as 4. If you want to be prudent, 4 inches would be okay. It would not be cubed because we didn't find the volume. We already had the volume. So you're set there as we go through. What I'd like you to do now is I'm going to show you these two problems, and I want to see if you can solve them. So you're going to have to take a look at them and then pause the video so that you can work them, and then I want to see if you can get them right. If you get them right, we did it. Awesome. If you didn't, don't worry, we'll have extra practice. So at this point, let's take a look at this first example. Number 1 up here. We have the figure. They want to find the volume, so notice your formula. They give us part of the base, and they give us part of the height. So go ahead and try to solve that one, and then come back when you're done. So pause it now, try to solve it, use a calculator, and then come back when you're ready. Okay, hopefully you paused it and solved it. You have some kind of an answer. If you get it wrong, it's all right. We'll figure it out later. But if you got it right, even better. So let's take a look. If you had this, you know to use your formula. Volume equals base times height. Your base is 4. That's the radius. So remember, we're going to have to use this. We're going to have to use pi times radius squared to get that base. And then we're going to multiply it by the height. According to the answer, you should have about 254 feet squared. If you had that, awesome. If you didn't, you probably made a mistake with squaring and with your thing here. Second example, let's try this one out. Now they're giving us the can here. They tell us the volume. They give us the diameter. Remember, that's diameter, not radius. And they want to figure out what the height is. It's just like the second example we did. So pause it now, solve it, write it down, figure it out, and come back. All right, so you're back. Let's see how it worked out. If it were me, I'd set up the formula. Always write down the formula so you have it, and then start solving it as you go through. This looked just like the example we did with this one right here, actually. So the same exact thing. If you get your answer, it tells me 11 divided by pi, which is about 3.5 centimeters. So hopefully that will show you how to do a little bit of this volume of a cylinder and height of a cylinder using all the formulas. It's a little tricky. You can do it. If you tried those two out and you got them right, then you're good to go. If you still want a little more practice, if you had the big ideas, I'll put a couple practice problems on there for you so you can try them out, probably about 5 problems, and just see how they go. You can check your answers right on there. And if you really love them, you can still go to Khan Academy and find even more problems with volumes of cylinders. Next up, we'll talk about volume of cones and spheres and other things. Thanks a lot. Hope it worked out well for you, and we'll see you tomorrow.